In this video, I'll show you how to build a Modbus RTU register reader in Python using ChatGPT, Copilot, or whichever LLM you prefer. This is especially useful when testing embedded Modbus RTU applications, or really any embedded system that exposes data through Modbus. If you've ever tested Modbus devices using a GUI tool, you already know that manually setting up each request really gets old fast. So let me show you a simple, scriptable approach that scales much better for testing and validation. Here's a quick example of what I mean. This is a basic Modbus map from one of my projects using STM32 and FreeRTOS. Here we have discrete inputs for alarms, input registers for live and historical sensor data, and holding registers for configuration parameters. This map gives us the structure of the data, but to generate a working reader, we also need a few additional details. That includes the serial communication parameters, the slave ID, how often we want to poll the device, and other details like which registers we want to read continuously versus only once, for example. Once that's clear, generating a Python-based Modbus reader is pretty straightforward. So the next step is simply describing these requirements in a clear prompt. Here's an example I used as a starting point. Here I specify the COM port, serial communication parameters, the slave ID, and which registers I want to read at the specified intervals. You can always review and adapt the output until you have what you need. And this is simply modern engineering, not cheating. This gets us what we need quickly. Now let's take a look at the basic Python script I have running based on this initial prompt. Here at the top of the file, we have the Modbus connection parameters based on the prompt, along with the polling interval. Next, we define the Modbus register maps, discrete inputs, input registers, and holding registers directly from the Modbus map. Further down, the Modbus client is created using those connection parameters. After that, we read the holding registers once at startup, since those represent configuration values that don't typically change unless written to. Then we enter a loop where we periodically read the discrete inputs, which represent alarms, and the input registers, which contain live and historical sensor data. So let's see what this looks like running on the target. Here's the Cube IDE in a debug session. In the live expressions window, you can see the discrete inputs and input registers updating as the sensor's task runs, along with the holding registers that define our alarm thresholds. In a real-world system, you won't always have the luxury of running in debug mode, and that's where a Python-based Modbus reader becomes extremely useful. You can also create test scenarios, for example, writing new threshold values, and asserting that alarms trigger correctly, or verifying that historical counters update as expected. This turns Modbus into a powerful validation and testing interface, not just a communications protocol. So let's switch over to VS Code and run the script. Okay, and once it's running, we can see live sensor values and alarm states updating in real time. Now I'll trigger a VOC alarm by spraying hand sanitizer near the VOC sensor. And the VOC index is now steadily rising. And there we go. The VOC alarm becomes active and the alarm counter increments. And once the sensor returns to normal, the application will clear the alarm. So that's a quick example of how easy it is to build a Modbus register reader using Python and an LLM. In my full STM32 FreeRTOS and Modbus course, we designed this firmware and Modbus application step by step. If you're interested, you can find the course link in the description.